In this lesson, we are going to learn how to do a realistic render. Because you saw in the previous lesson that our hamburger did work, so we had the burger in the scene, but the colors were so wrong and it didn't look realistic at all. So there are many things that can participate in a wrong looking model. All right, there is the modeling part, we know that, but we are going more to talk about just the feeling, the colors, the stuff like that, some details maybe you didn't see. And we are going to learn all those techniques and improve the model and the how it looks. About the setup, well, instead of a burger, we are going to use the flight helmet. At the end of the lesson, do not worry, we are going to try with the burger and we'll learn even more things. But for now, we are going to use the flight helmet, which is a much realistic model you will see shortly. We actually did use it already when we were trying to load more complex model, you know, with the pipes, stuff like that, the glasses, you will see later. It's also a good way to revise what we learned from now. So as you can see in the setup, we don't have much, so we will do everything again. Not everything, but all the loading part, instantiating the loader, stuff like that. And we will add quite a lot of things to that GUI so that we can control the way our render look, because that's important. If you want to have a realistic render, you must be able to tweak everything slightly, move the light a little, increase its intensity, change this color and stuff like that. That's important, and we are going to do it together in this lesson. So yeah, first what we can do is set the lights, because we are going to need lights. And to start with, because the current sphere is using a mesh basic material, we cannot see the light. So what we can do first is change the mesh basic material to a mesh standard material. Because we want a realistic model, we need to use a mesh standard material. You know that. So yeah, let's go. As you can see, nothing anymore because we don't have any light. If you check the code, you will see that there is no light. So our sphere is still here, but we just cannot see it anymore. Okay, cool. So let's add some light. And actually, we will just add one small directional light. And that's all. Because we are going to use the environment map to illuminate the model. We talked about this, just talked about this. You can use the environment map so that the colors of the environment map is applied to the model. We are going to do that later, all right? If you forgot about this, we just talk about this, so it's okay. We are going to do that together. But still, we need one directional light, because this directional light will provide us more control and also the shadows. You will see when we will be able to tweak both the environment map and the directional light, it will be perfect, you will see. So yeah, let's go. We can put the code. Let me check. Well, we can put it there. Let's go. I'm going to call it light. Yeah, why not? And we can create the directional light. You can call it sun or something like that, but we will only have one directional light, so it's okay to call it just directional light. 3 directional light. Maybe you remember about this. Anyway, it's a perfect opportunity to see it again. And we will go for just a white light, and I think it will be great. We can actually tweak this one, but I don't get any good result by using other colors. You will see that later. So if you want to tweak it, you will be able to add it to that GUI, but we won't do that. I'm talking about the color. We will add the intensity and stuff like that to that GUI. Then we can choose a position, but we are going to be able to change it anyway, but let's use the position I will provide you. So yet again, position set 0.25, 3 minus 2.25. Then we can add it to the scene. As always, if you forget to add it to the scene, that won't work. I recommend you to use those values. Follow me on this, all right? At the end, you will be able to tweak as you want, but follow me on this so that we get the exact same result to start with. All right, as you can see, we have one directional light, meaning that the back of the core shadow, the back of the sphere is the core shadow. It's fully black, and this part is visible. Looking good. Not that good, but it's going to look great. Then we can add some tweaks to that GUI, so let's go. Pretty straightforward. We are going to be able to tweak the intensity of the light, so it's going to be directional light and the property intensity. I know I'm going quite fast, sorry, because we already saw these. All right, try to keep up. Don't hesitate to pause the video. And we are going to provide a name like light intensity. I like to use a camel case in the name so that it doesn't take much place. So yeah, we added the intensity so that we can play with the intensity. It's not looking great. We are going to talk about this right after. Then we can add the directional light position object and play with its X. The mean value can be negative, -5. The max value can be positive. So 5. I'm going to use the same precision. So the step, light X, and then we can duplicate it for the X, Y, and Z with the same minimum value, maximum value, and then you can change it there and there. All right, we added the X, Y, and Z properties to the tweaks, to that GUI of the position. All right, it has to be on the position because we are playing with this vector 3. We save and we get something like that, which enable changing the lights just as you want. So you can make a light that go from the ground, which is kind of strange. Maybe we could have put a limit to 0 for the Y. Anyway, we don't really care about this. It's not that important. Cool, we will be able to tweak the light as we go. All right, so our directional light is working. The default 3GS light intensities are based on arbitrary scale unit and don't reflect real-world values. What I mean by that is something like if you put, I don't know, 1 as the intensity, it's just 1, we don't care what. And it looks like this, all right? Why not? Because we can set everything just like that, but it's not physically correct. And if you get values between different software, different engines, stuff like that, you might have inconsistency. You might have different values between those because some use arbitrary values, some other arbitrary values, and some use physically correct values. And this is exactly what we are going to do. We are going to tell 3GS to use physically correct light values. To do that, you have to do it on the renderer. So where is my renderer? It's over there. So get down to the renderer and you can do renderer physically, it's hard to write, correct light equal true. Look the difference. Yeah, as you can see, it's just not that intense. Like it's like the light has been dimmed. And if we had other lights, we would have get the same result. Like we can see much of a light, but this is physically correct. So we are going to base the values on that. So get back to the directional light and just increase the intensity, and we can go like 3. And as you can see, it feels the same, but now we have physically correct value, and it will be easier to get the same result between different softwares. Like if you export from Blender and you have lights in your exported model, you will get the same light between Blender and 3GS. All right, cool. Let's move forward. So it's a beautiful sphere, but we want our beautiful model. So let's go. First, you can import the GLTF loader because it's a GLTF loader. Import, if you remember the syntax, they are all different. But anyway, it was GLTF loader from, and we get it right from straight from the 3 dependency. Examples, GSM loaders, GLTF loader.js. I got it right. Let's just console it. Oh, all right, it's working. I don't know what's that, but still it's working. That's great. Then we can instantiate the loaders. We can do that, well, at the beginning of the code, right after the import. So let's go. We're going to have multiple loaders in this exercise. So in this lesson, so let's group the loaders together. It's not that important, but I like to do that. This way I group the loaders, but also the loading. So that you, in just a few lines of code, you have everything about loading with the loading manager and stuff like that. So new GLTF loader, maybe you remember from the previous lessons, just save, no error. Let's continue. If you have an error, check the error and get back to the lesson once it's fixed. Do we need a Draco loader? Well, no, because the model we are going to use is not Draco compressed. But if you want to use a model that has been compressed, let's say your burger, maybe you compressed your burger, you will have to instantiate the Draco loader. It's up to you. We will do it at the end of the lesson. I will provide you a burger not compressed, so you can use this one. But if you want to use one, you have two options. You can instantiate the Draco loader here, so just like we did in one of the previous lessons, or you can just re-export your burger and uncheck the compression so that your burger is not compressed. It's up to you. It will be at the end. For now, just focus on what we are doing with the flight helmet. And yeah, right now we are going to load the flight helmet, so let's go. I'm going to set a models part, and it's going to be before the light. Yeah, why not? So right before the light, you can do models gltf loader load, and then you have to provide two parameters. It's going to be the path to load the model. So my model is over, so it's in static models flight helmet. You can see that the burger is ready. So it's inside this, and that's a long path, and this is the one we want. All right. So it's going to be slash models with an S, flight helmet. Be careful with the uppercase. Helmet slash GL lowercase TF uppercase. Flight helmet. Can do mistakes here. Maybe I will do one. GLTF. And then you have the success callback function to provide. So I'm going to use a fat arrow that looks like this. And then you can do gltf to get what has been loaded. And you can put, I don't know, success. Yeah, why not? And gltf. Let's see if I got it right. Yeah, I did. All right. If you did a mistake in the path, just make sure everything is written properly, and until you get your success log and your gltf variable in the logs too. So what do we have? Maybe you remember we have the scene. This is where we can catch everything that has been loaded, and inside the scene we have many children. Maybe you remember the different techniques to load to add the model to the scene. We are going to do the simplest version, which is scene add, and do gltf.scene like that. Where is my helmet? No error, just zoom in. All right, here is my helmet. It's just too small. It's inside the sphere. So let's crank the scale up. You can do it. Oh yeah, remember we did gltf scene because this is a group. If you remember, I can log it if you need. This is just a group. I know it's called scene, but it's not a 3GS scene. In fact, it's just a group, as you can see here. The same kind of group we use to group the element of the house. So we can just add it, and because it's a group, we can play with its position, rotation, and scale. So let's go. Just use my value, but if you want to use different values, well, you can. So scale set, I'm going to use 10, 10, 10, so that my helmet is 10 times bigger. As you can see, that's much better. We can't see much, do not worry, you will see it perfectly soon. Then we can play with its position, and we are going to use 0, -4, 0. So it's lower on the y-axis, so it will just be lower. And then we can do rotation and just rotate it. I don't know why exactly. Rotation Y. Oh, just on the Y so that it faces the camera better. Let's see what we get. Yeah. All right. Yeah, it's almost at in front of the camera. We don't want it like straight at the front of the camera. We just want it to see it on the side because it just looks great. All right, that's cool. We can add the rotation of the helmet to that GUI so that we can just find the perfect angle once we have everything set. To do that, you can do GUI add, and you have to do it inside the success callback, because if you do it before, it won't work because we don't have our model yet. So GUI add, we can do it on gltf scene rotation, we want to tweak its Y value with a minimum. We want it to be able to do like a full rotation. So it's minus pi to positive pi, or 0 to 2 times pi. Remember this one? Anyway, if you don't, that's okay. Just trust me, minus pi will be half a circle in a direction, and positive pi, so just math pi, will be on the opposite. So it's the mean value and the max value. Maybe it's the other direction. It's not that important. And then we can set the step. I'm going to use 0.001 and use the name. I know it's a huge line. Rotation, just rotation, like that. If you don't like having such huge line, what you can do is something like that, that, and that. It's the same. And what we get, oh, I did a mistake. GLTF scene, again, I have to fix this one. Sorry. I tried. I don't know what I did, but I don't get the rotation every time VS Code is trying to give me those method, which mess with everything. So the minimum value, sorry, I did min twice. That's a lot of mistakes. You probably saw those mistakes. Great job. I didn't. So yeah, as you can see, I can go from this position, this rotation, sorry, to the perfect opposite, which is a full rotation. All right. We don't care about this now, but once our setup is perfect, we'll be able to tweak. So it's even more perfect. All right. That was just an example. And let's add the environment map because I want to see things. You cannot see much here. As we said earlier, the lighting will be taken care of mostly by the environment map. So we need to set up the environment map. Maybe you remember about environment map. It's like you have two possibilities. It can be, it has to be like a photo of the surrounding, but it can be like one huge image which is stretched, like if it was a sphere around the image, 360 photo, or it can be 6 photos, one on each side, so right, left, front, back, top, and bottom, and you get like a cube, like if you were inside a cube, and you have textures on each face of the cube that looks like the surrounding. In 3GS, we have to use the 6 photos, which is a cube texture. Yeah, we will use it both in the background because we don't like this black background. We are going to put the environment map in the background, but also to eliminate the models. So yeah, let's load the environment map. We have some textures located inside the texture and then environment maps folder. I put 4 values, 4 texture. You have this one, you have this one, you have street, and you have another street looking great. Yeah, cool. So first we need to load those. We need to load cube textures. So we need the cube texture loader. Remember this one? Let's go. Cube texture loader equal new 3 cube texture loader. And this one is available in the 3 variable. Great. Always check if you did a mistake. Maybe I did. No error. Seems to be looking great. Then we can load those textures, and we are going to load them, let's say, yeah, right before the models. Actually, you can get rid of the sphere. I forgot about this. So remove the sphere if you still have it. And here, so right before the model, you're going to load the environment map. It's important because we are going to apply things about the environment map on the scene, so you have to do it after the scene. You can load the environment map at the beginning and then update the sphere, but this time we are going to do things a little differently. So environment map, and then we can load it, and we are going to create a variable, environment map, environment map equal texture loader. Let me check if I did it right. All right, it was well written. Load, we pass an array because we have multiple textures to provide. Those are the texture. And as you can see, the names are NX, NY, NZ, PX, PY, PZ. It's X, and you have N for negative and P for positive. And the order is the following one. It's NX, x.jpg. I know the path is not complete. Then it's it's positive x, negative x, and then positive y, negative y, and then positive z, negative z. All right, and then you can add the full path. So you do whatever you want. Environment, I mean on the way that you get those, and it should be something like that. All right. And we can get the result, the texture directly inside this variable. We don't have to use the success callback or stuff like that. Let's test if I got it right. Yes. If you did any mistake, I don't know, you maybe load a one that doesn't exist, or you did a mistake inside the path, something like that, you get a lot of errors. Fix the errors. Get back to the video once it's fixed. Cool, I think we did load the environment map nicely. Let's apply it to the background first. And this is really easy. And I like when it's that easy because things are getting more complicated on each lesson. This one is not that hard. To apply the environment map on the back, on the background of our render, you can do scene background equal environment map, and that's all. So make sure that you declare the environment map after the scene, or you won't be able to change things on the scene. Save, and you get this. All right, this is great. Finally, something easy. So the colors are wrong on our model. I mean, it's like there is almost no light, but still we can see the environment map in the background. Sorry, I moved the camera a lot while I talk. So yeah, next step is about applying the environment map to the model. To do that, we can apply the environment map on the material with the env map property. All right, we need to use the env map property on each concerned material, which is not that easy because the materials are located inside the elements of the children of our model, and we can have like children inside children inside children inside children. This is not the case. Just look at my my screen. If I do something like that, you will see that it's not that complex. The people that did this model did a great job because we only have the meshes right inside the group, the scene, which is great. But sometimes you have a much more complex model with groups, inside objects, inside meshes and stuff like that, and it's a mess. And it can be really hard to traverse the scene and apply the environment map on each mesh and each material of the mesh. So we are going to see a technique to do it right, whatever the material you are using, whatever the model you are using. To do that, we can use the scene traverse, all right? And we're going to traverse the whole scene, not just the scene we loaded, so not just the model, the whole scene. Thing is, we only have our model in the scene, but still, if you had, I don't know, you add cubes, spheres, Suzanne, stuff like that, other models, it will go through every element of the whole scene, which can be better for you. So yeah, let's go. Instead of doing it here when we loaded the model, we are going to create a function to do that. We're going to position, it's going to be before the environment map, so I can do update all materials, and we are going to create a function to do that. If we call this function, all the materials on our scene will be updated. So let's go. Const update all materials. We see that this one will be very handy later, which is why we create a function. Scene, and we are going to use traverse. And traverse will go through each child of the scene, but also each child of each child, and again and again and again. It's recursive. You will get every object, whatever how deep they are inside the scene graph. Then you have to provide a function. So I use fat arrow as always, and you can just write child, and this function will be called for each child. And what you can do is just log the child because we want to understand this part. If I save, nothing changed and we have nothing in the logs because we only created a function. Now we need to call this function. So you can call this function and you can call it, well, we can call it here after adding everything to the scene. right? You load the model, you add it to the scene, you tweak it, and then you update its materials. The material of the whole scene, actually. And as you can see, we get a lot of logs. We get the scene, the directional light, we get the perspective camera that we are using right now, we get a group, okay, that's the GRTF scene, and we get every mesh. And if you add more objects, I don't know, you added a cube, cylinder, stuff like that, we get them here too. But we want to apply our environment map only on the materials, which are supposed to be mesh standard material, so materials of the meshes, all right? How can we do that? Because we don't want to apply the environment map to the directional light. That makes no sense. Or to the camera, or to this group. We only want to apply to a mesh that has a mesh standard material. Well, to do that, we are going to use instance of, so it's just a JavaScript, and we can do if the child is an instance of 3, so the 3 mesh class. We didn't use new 3, or we are just testing, is this child an instance of 3 mesh? And this child materials, so materials, is a material without an S, is an instance of 3 mesh standard material. All right? So if it's a mesh and its material is a mesh standard material, then we are going to start by just logging it to make sure that it's working. And as you can see, only the mesh having a mesh standard material has been logged. And if you use, I don't know, a cube with a mesh basic material, you won't get it here, which is perfect because the mesh basic material, you can apply an environment map on this one. So that's great. Then we can change the environment map and we can do child material and use, as we said earlier, env map and use our environment map. I know it's declared after, but this function will be called when the model is loaded and then the environment map will exist. So it's not a problem. I know it's before environment map, but this function will be called after, so it will work. Let's save. Maybe it changed. I don't know. Let's make sure of that. What you can do is crank up the env map intensity and use something like 5. All right, that's better. Still not realistic, but much better. And if you crank it up even more, well, you get more effect. How can we find the right value? Well, you can guess it. We are going to add this part to that GUI. The problem is that this is a value on each material. So if you have, I don't know, 20 materials in your scene, you don't want to have 20 tweaks here. We want only one tweak to control all the env map intensity, all right? One tweak to control all env map intensity, so for every materials. So how can we do that? Because it has nothing to do with the current object, we want one tweak to control many things, but we currently have no object that can do that. What we are going to do is somewhere over the .GUI. Where is my .GUI? All right, it's here. We are going to create a debug object. So let's go. Const debug object. The only purpose of this debug object will be to contain things that cannot be elsewhere. So we need properties is inside any debug object to be able to tweak them. Then you can get back to the environment map, and yeah, we can put it inside the environment map section, and we are going to do debug object and create one. So it's going to be env. We're going to use the same name, map intensity, and we are going to use 5. Why not? We are going to be going to tweak it anyway. And we can add this one to that GUI. So it's going to be GUI add debug object, and it's going to be this one. So we are just adding a tweak out from anywhere with a minimum value. I don't know, let's use 0, max, yeah, 10 is more than enough, and use a step somewhere like 0.001 like the other ones. All right, what we did here is create this environment map tweak, and we change it We can change it, but it doesn't change anything here because we are just tweaking this property and we are not using this property. So the next step will be to use this property on our traverse function here. So let's go. Well, you can just do that. So you take this debug object environment map and intensity. So it's our property and put it there. All right. So for now, it seems to be working again. And if I change the value, it's still not working because we are applying it just once. Your update all materials is just called once here when the model is loaded. All right. If you want to apply the new map intensity when you change it, first you need to be aware that it did change and then apply it again. And we know how to do that. We know how to ask that UI to tell us when a tweak change. We can do on change or on finish change, but this time we're going to use on change, and we can provide a function to it and do something inside of it. Log do the tweak like that. And as you can see, when I change the value, my log is being called like this. It's working. So here we should update the materials. What we can do is call update all materials. So instead of logging something, when the on change occurs, it's going to call this function. And in this function, we call update materials. Yeah, I know there is a shorter version. Let's just check if it's working. And yes, you see that it's working. We now have one tweak to control all env map intensity like this. But there is a much more simple way of writing this. Instead of creating a function that calls a function, we'll just provide the function like this. All right, we just provide this function. When the tweak change, update all materials will be called. And then we can do that. It's the same result. That's great. We now have control over the environment map intensity. Then there is a much easier way of doing that. I know I could have shown you the easier way at the beginning, but still I wanted you to practice a little the fact of traversing the scene, only targeting mesh standard material, stuff like that. So it was a good training. We are going to need this anyway. All right, so it's not for nothing, but there is a much simpler way. What you can do is on your scene, so you can do it right after having loaded the environment map right here. What you can do instead of updating each material to apply the environment map is to do scene environment equal environment map. All right, just do that and it will apply the environment map on every material supporting the environment map. And you can remove this part like this. And as you can see, we get the same result. Still, we need it because we want to be able to control the intensity, and you cannot control the intensity of the environment map on the scene. So it's still useful, but if you want to just apply the environment map on every materials, you can do scene environment map, just like we did scene background. Okay. Let's talk about the renderer because it's looking better. But still, as you can see, that's not realistic at all. We need to improve that. We're going to work on the WebGL renderer. First, we need to talk about output encoding. I'm not an expert about encoding, but still I will try to provide you the information I've learned. The output encoding property controls the output render encoding. The default one is the default output encoding is linear encoding, and we should use sRGB encoding. And I'm going to explain this right after. So go to your renderer. Where is my renderer? It's over there, and you can do output encoding equal 3 sRGB encoding like this. And as you can see, it's much better. Right now, just by doing this, it looks great. The light seems much better. We still are missing few stuff. We have to talk about this tear-like effect. We are missing the shadow, stuff like that. And we want more control, but still it's looking great. Just by doing a renderer output encoding 3 sRGB encoding. We use sRGB encoding, and another value could have been gamma encoding. The gamma encoding lets you control this effect we just had right now. So it's like being able to control the brightness. This is not right. The gamma encoding purpose is not just to play with the brightness, but usually people use the gamma encoding in order to play with the brightness by using the gamma factor. We are not going to do that because it's not physically right. It's not the right way of using it, but also because we are going to see another solution. So yeah, let's try to understand those sRGB, gamma factor, and stuff like that. The idea is that when you store a value, I'm bad at this, but still I will try to explain that to you. When you store a value, don't mind the grid. We're going to talk about the grid later. When you try to store, let's say, a value, instead of talking about RGB, stuff like that, we are going to store a more simple thing like black and white. So this is black, all right, and this is white. When you try to save those values, well, if you use the linear encoding, which was the one where 3GS is using by default, if you get, I don't know, 0.5, so it's, I'm going to use other color. So if you get 0.5, I'm going to put it there, it will look gray. You agree with me? If you use 0.75, it will look like half the path to the white, so more white. And if you use 0.25, you will get 0.25. So no surprise, this is a linear encoding. We get the same result at the end. The idea is that your eyes can perceive light differently from a linear encoding, meaning that if we send a value that goes from 0 to 1, your eyes will perceive the brightness differently. It's about sensitivity of your eyes. And it's something like if I show you a difference between 0 and 0.1 in the black, maybe we see like a huge difference. But if I show you like if it's this one, you will see a huge difference. So you can tell, yeah, it's much brighter. But if I show you between 0.9 and 1, you won't see much of the difference. This is the way your eyes will work. Maybe it's the opposite actually, but let's think about it this way. So here we can see much of a difference, and here we cannot see much of a difference. So it would be a waste of information to have values that can go from 0 to 0.1, 0.1 here, because our eyes cannot perceive much of a difference. What the sRGB thing, the gamma encoding thing are doing is that instead of getting the linear value, meaning that 0.25 will give you 0.25, we'll get something else. The values will be deformed, like encoding differently. I will have it like this. All right. Instead of having 0.25, so the 0 will be 0, so this won't change, and the 0.25 will end up over here, right here. And the 0.5 will end up over here. And the 0.75 will end up over here. And as you can see, it takes more time to increase the value. But this way, we get more precision when we are at very small value, where our eyes can perceive those values. All right, so we get more here. I will use another color. So we get very small value like this, so we can be very precise. And the higher the difference is here. But our eyes cannot perceive this part much, so it will be fine. All right, we are just going from 0 to 1, from black to white, but in a more optimized way of storing values, because our eyes are not that sensitive to changes here. The problem is that if an image, a texture, a color is using this conversion and you are not using it right, well, you will get the wrong value. So when we get an image that is gamma encoded or using sRGB encoding, and we don't know about that, we have to convert it back to the right value. If you don't convert it back, you get the wrong color. And this is exactly what's happening here. We are not converting it back. when we are using this, it's the linear encoding. We are not converting the values that has been like squeezed to have improved the precision. We don't unsqueeze it and we get the wrong color. And this is why we get this strange thing that is not realistic at all. All right, that was my attempt to explain to you what sRGB and gamma factor are. The sRGB is like a gamma factor of 2.2. It's not right, but for 3GS, I think it's kind of work exactly like that. So you get the same result as 2.2. And this is the common value, all right? It's like people agreed on that because there are maybe scientific reason, like the eyes, physically reason. But using sRGB, it's like using a gamma factor of 2, almost. Anyway, I put some article about that. You can check on the links as always. I put 2 articles. There is only one here, so check the links. There is 2 articles at the bottom of the links panel. Check those. They will probably explain to you much better than me. So check those. Let's get back to the sRGB encoding. And let's talk about texture encoding. So this sRGB encoding and decoding thing can apply to everything using colors. And the fact is that our environment map colors are wrong. As you can see, they look kind of grayish. The tone down, like it doesn't look right. It looks much better, but it's not right. The problem is that the render output encoding is sRGB encoding. Yes, so we did that. But the environment map texture by default uses linear encoding. And it's because we loaded the environment map and we didn't say, all right, this is using the sRGB encoding. So we need to fix that. When we load the environment map, what we need to do is change its encoding. So we can do environment map. So it's going to be right after loading it. Encoding equal and use the 3 sRGB encoding like that. And now it's looking great. I know it's not as like washed down like a grayish thing. Maybe you prefer the grayish result. Don't worry, we'll get to a similar result shortly. But right now, everything are getting right. We get the right value, at least in the back. So yeah, that's better. By the way, I forgot about this. The idea is that if you're using a texture that you can see in your render, like the texture on the back here, the textures on the model, stuff like that, you have to use sRGB encoding. It's not mandatory, but it's usually the right encoding. So just apply sRGB encoding on the textures you can see. But if you are using, let's say, textures like we can check inside the folder. So the environment map textures, we can see those. So we have to use sRGB encoding. But if you look at the models, as you can see, there are other kinds of textures. And you know about this one, it's the normal texture. This one, do not apply the sRGB encoding on it. All right, we want the straight values. We want those values, like if it's 0.5 on the red or something like that, we want 0.5. And if it's 0.25. If it's 0.5, we want 0.5. And if it's 0.75, we want 0.75. We don't want to change and squeeze the value. We want the exact value from the pixel on that textures. So if you can see the textures, like the one we can see here, you apply sRGB encoding, and the other one, you use linear encoding. But what about those model textures? We didn't set sRGB on those textures. Well, it's because, unfortunately, the GLTF loader implemented this rule, and all the texture loaded from it will have the right encoding automatically. So we didn't had to say that these textures, like this one, has to use the sRGB encoding, and this one has to use the sRGB encoding. The GLTF loader did it. Great. So it's more realistic, but as you can see, we kind of like what happened with the grayish render, and we can get a similar result. But now we have the right values, which is better. We have a great base. We have to do like a pyramid. We start with a great base. If you got your base wrong, you cannot do a great pyramid. So we are going to talk about the tone mapping. And it's funny because we are not going to use it right, but still it will look great. You will see. The tone mapping intends to convert high dynamic range, so it's HDR, we talk about HDR, so it's high dynamic range values to low dynamic range, LDR. Yet again, I'm not an expert, but I will try to explain to you what's happening here. HDR is much more than what I'm going to tell you, but you can see that like an image, where the color values can go beyond 1. Let's think of, I will take this paper, this sheet, and I put a light. So maybe it's like a white for you. All right, so this should be like a value of 1. Like if it's fully white, it should be a value of 1. We agree on that, right? But what if I turn the camera, I won't do it, but I turn the camera to the light, like straight to the light, looking at the light. Shouldn't the value be higher than that? So it was white here, and here you will get white, but this is wrong because the light should be more intense. Like it should just, you be blind of looking at the light. So we have a problem. It's like having a limit. And this is exactly what's happening. The idea is that if you take a pictures, we get a value from 0 to 1, something like that. So it will be black and white again. All right. When you save default low dynamic range value, where it goes from 0 to 1. The idea with HDR is that you're going to save values that can go from black to, and it's not going to be white or something like that. It can be anything, right? It can be much higher. I will stop there because I need the space for the rest of the lesson, but the value can go beyond 1, all right? But question is how you get from this value to this value. All right, it's going to be from the right to the left, because at the end you have a screen with pixels where you need something that goes from 0 to 1. Here again, we are talking about black and white, but it's more about RGB. It's just simpler to think about black and white. So we have to apply this to RGB. So it's the same thing. So how do we get from this value to this value? Well, this is exactly what's happening with the tone mapping. The tone mapping will use those values that can go from crazy value because we are looking at the sun or thing like that, and use an algorithm to move it back to a 0.1 value. And maybe it will do something like that, and this one will end up there, and this one will end up there, and this one will end up there, and maybe there will be more over there or something like that. And this is the algorithm part. And we can use the algorithm, and we can also control parameters. It's going to be the exposure on how much light can go in. Like, do we allow lights that come from much higher, like, I don't know, over there? Do we allow light that goes from here to be squeezed into our black and white value? Yes, no, maybe. It's kind of the exposure parameters. So as you can see, I'm not an expert on that. Still, I'm trying to give you some knowledge so that you can maybe understand better after. And if you did understand and you know better, just explain to me. I can't wait to know better about this. Anyway, this is what I understood. And we are going to use the tone mapping because 3GS does support tone mapping. So the tone mapping is the algorithm for going from HDR values to LDR values, low dynamic range values. But you might think, and this is the point I almost forgot to tell you, we are not using HDR textures, HDR environment map. Yeah, so why would we use the tone mapping if we are not using those values that can go beyond 1? Well, it's because it will just look great. We are going to use textures that go from 0 to 1, which are kind of normal textures, and we are standard textures, and we are going to use this algorithm to get normal textures, so standard textures again. But it will look great. You will see. I know this is not the purpose of tone mapping, but still it will look great. To use it, we have to go on our renderer, which is over there, and you can use the tone mapping property, and you have different values. What you can do is just test any one of them. Let's use the Reynard tone mapping, and as you can see, it's look different. All right, let's use another one. So Kineon tone mapping. I hope it's Kineon, and it's look really different. It's looking great, actually. It depends on what you want to achieve. And let's use the ACES filmic tone mapping, and I really like this one. Like, see the colors? It's looking really cool. I really like this one. So yeah, you can test them. And a better things would be to add it to the tweaks as always. So yeah, let's go. Unfortunately, we are going to have a problem. You can add a select to the that UI. To do that, you can use add again. So it's going to be on our renderer because this is the tone mapping property. The second parameter is going to be, well, tone mapping. All right, we want to tweak this and be able to provide the no tone mapping, linear tone mapping, rendered tone mapping, Kineon tone mapping, and ACES tone mapping. And to have a select instead of a value like this, you can provide an object, and you will have to choose the name for the property. This is the part that will be shown in the select. And we want this one to be no tone mapping. You will see the result shortly. This one will be linear. So it's going to be linear tone mapping. I hope I wrote it right. Rain hard. It's probably not the right way of saying those. Kineon tone mapping. Sorry. ACES filmic tone mapping. All right. So as you can see, I provided an object. The names of the property will be visible on the select. And when you choose one of those values, you will get this value. All right. The value inside the object. And we get this. All right. So it seems to be working. Be careful. If you try to change it, unsupported tone mapping. It kind of changed. We got another. Oh no, it's not working. Yeah. No, it's not really working. So we have a problem, and this is actually a bug. This has nothing to do with 3GS. Our code was right, but the problem is that those values, let me show you those values. Those values, no tone mapping, are constant, 3GS content, that are numbers, all right? They look like this. Like I use Kineon tone mapping, I get 3. The problem when we change the value using this way is that, I don't know if it's 3GS or that UI, it's more a 3GS problem, but those values will be converted to string. All right, so instead of having 3, we're going to have 3. And you cannot use 3 here. You get an error. All right, so this is the problem. Those values get converted to strings automatically. I don't know if it's JavaScript issue or that UI issue. Anyway, they get converted, and it's wrong because 3GS don't understand if it's a string. What we can do to fix that is use, I'm going to do some line breaks because I like things well organized, and do on finish change. So when the value change, we call this callback, and we convert it back to a number. So we do renderer tone mapping equal number, and this is just JavaScript. It's a way of converting to number, the tone mapping. So this, unfortunately, was a string, and we convert it back to a number and apply it back again on the renderer tone mapping. So this is just a bug, unfortunate bug, and now you can see that we can control it. But wait, it seems to be working, but only on the background. And this is true. It's only working in the environment map on the background, not on the model. So we need to fix that. Yeah, this part is a little hard. To fix that, we need to tell the materials to update themselves. And well, actually, we already have this. So this is the function that is doing the update material. And what you need to do, so I changed it, but anyway, we can do it there, is do child material needs update. Needs update equal true. So right now we are traversing the scene. We are changing the map intensity. We did that for that reason. And we are going to say needs update equal true. All right. It doesn't change anything about the map intensity. But now that we did that, all we need to do when we change the tone mapping, which is over there, we are going to call this update all materials. All right. I told you this one is going to be handy, and it's the case here. We update the tone mapping and we tell all the materials to update themselves. And in the update all materials, we use needs update true, and this will apply the new tone mapping. Let's try it. I use Kineon, Reynard, no tone mapping, and as you can see, it looks great. We get our grayish render back. We get my favorite one is ACES. Well, it depends on what you want to achieve. It depends on your project, the style you want to get. But I really like this one, ACES, Filmic Tone Mapping. All right, looking great. And by the way, you can also control the tone mapping exposure. All right, it's like the how much light the algorithm will let in. We can control that. So let's get back to the renderer. So it's on the renderer itself, and we can do tone mapping exposure like this. And you can use another value, let's say 3. And as you can see, we let more light in. So it's like summer vibes, stuff like that. And you can try with other ones. And you get a great result. All right, it's looking really cool. Obviously, we're going to add it to that GUI. So let's go. It's going to be right after the select. I'm going to do GUI add. It's on my renderer. The name of the property is tone mapping exposure. And we will use min 0, max 10, and step 0.001. And as you can see, I get this tone mapping tweak and I can play with it. You can try to find the perfect value and the one you like. So I won't be doing it. I will use the values from the lesson. And yeah, we are going to go for the Renard tone mapping for the rest of the lesson. So you can just change it if you want the same as me. But I really like the ACEF Filmic tone mapping. But if you want the same result as me, use the Renard tone mapping. It looks kind of grayish. I really like this one. It's really realistic, like a wrongly set up camera. I think it looks really realistic. All right, the next part is about anti-aliasing. And if you're a gamer, you probably heard about it. The anti-aliasing, I hope you can see it on the video. Anyway, test on your screen. I hope you can test it on the screen. I will explain to you maybe why you cannot test on the screen. But here, you see, I get a stair-like effect right here. It's not looking great, all right? Maybe you cannot see it, and I will explain to you why. So, we call anti-aliasing an artifact that might appear in some situations where we can see a stair-like effect, usually on the edges of the geometry. Not only, like if you have, I don't know, maybe like squares or chess or something like that, you know, like a grid, grid texture, you will be able to see this aliasing thing, this stair-like effect. This is due to the render having to choose if the geometry is in the pixel or not. And I can provide you a drawing. I like to draw, as you can see. Let's see, we have a sphere. All right, but we are going to zoom on this part of the sphere. So we get something like that. All right. Okay, looking great. When the WebGL will render our geometry, it will first ask if this pixel is inside the geometry, if this pixel is inside the geometry, etc. for all the pixels. So is this pixel on the geometry? Yes. Is this one on it? No, because it's mostly outside. This one, yes, yes, no, yes, yes, no. So we have something like that, that. This one, no, yes, yes. I will do some just to have enough material, enough things like that, and I think that's enough. All right, so we get something like that, and the rest is not on it. So this one is not. Yeah, a little more, something like that. So how was your weekend? Good weather today. All right, cool. And we get that. And as you can see, we get the stair-like effect, just like that. All right? Which is why we have a visible stair-like effect. Because those, maybe I forgot to say, but those are the pixels of your screen. And the geometry has to decide if it's on it or not. This is why we get this stair-like effect. This is a common problem. Developers doing like a real-time rendering, Unity, Unreal Engine, it's been always there, and we have solutions, all right? The first solution we can do would be to increase the size of the renderer by 2 or more, but let's increase the size of the renderer by 2. And we will get, like, let's say we're going to focus, I don't know, just on this pixel. We're going to cut it into there. So we do a twice as big renderer, and then we scale it down to that. This way we get more precision, like this one is in, this one is in, this one is in, this one is not. And because we are scaling it down, those will be average. So we get a mix between yes and no. All right, that's great. Maybe we can do that. So this technique is called super sampling, so SSAA, or full screen sampling. All right, there is two ways of saying it. So FSAA. Yeah, it's easy. We can do it like very easily. It's very efficient, but you have to do 4 times more pixels to render, which is a lot. So maybe it's not the right idea. If you have like performances are just great, you don't have much on your scene, it works perfectly on bad computers, well, maybe you can use super sampling. And actually I did it on my portfolio. That wasn't maybe not the best idea, but the performances was so great that I say, okay, let's go for super sampling. And it seems to be okay. Another solution is named multi-sampling. It's MSAA. There are many more solutions. We are going to discover some of them later, but just let's talk about the super sampling we just discovered. And we said it's a bad idea because it's bad for performances. Here we have a lot of polygons, a lot of textures. It's a bad idea to go for super sampling. Another solution is called multi-sampling. So it's MSAA. It's the same thing, kind of the same thing. It's a little harder. Maybe check articles if you want to know more. But the idea is that we will do that only on the edges, because the super sampling will do it on every pixels. Like this one will be divided by 2 horizontally and vertically, this one 2, this one 2, this one 2. But all of those are already on the geometry, so it's not important. We know that this one is going to be green, 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 green. Well, it's green. Green, 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 green. It's green. Green, 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 green. It's green and it's green. All right. That makes no sense to use super sampling for this part of the geometry. What the multi-sampling will do is that, but only on the edges of the geometry. So there, 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 there. So it's not that hard because it's only on the edges of the geometry. It's much better. You can get good performances and still get rid of those stair-like effects. So yeah, the multi-sampling will do multiple renders on each pixel, and then we'll average the final value to provide you the pixel color. And by the way, most recent GPU can perform this multi-sampling anti-aliasing, and 3GS handles the setup automatically. Yay, great, we don't have anything to do but to activate this multi-sampling. So let's go. To do that, you cannot, be careful. There is one mistake I saw many times, is someone doing anti-alias. Like this equal true. This won't work. You have to provide the anti-alias when instantiating the WebGL renderer. All right? You have no choice. You have to do it there because 3GS will do something at the beginning. I won't explain why. We don't need to understand why, but you have to provide the anti-alias true to activate the multi-sampling when you instantiate, not after. Make sure of that. And as you can see, I hope you can see on my computer, but the stair-like effect is gone. It just looks perfect. Almost. Maybe you can still see it. Maybe we can see some moire, but still we cannot see the stair-like effect. So it's looking great. By the way, maybe some of you could not see that problem. Well, it's because maybe you are using a screen with a pixel ratio above 1. Me, I'm using a pixel ratio of 1, meaning that I have standard pixels, which means that I can see this stair-like effect. But if you have a pixel ratio of 2, you have much more, 2 or more, but we did a limit to 2. You have much more small pixels, so maybe you cannot see the stair-like effect. So why would you activate the anti-alias if you don't have the problem? Well, this is actually a good thing because later we're going to activate the anti-alias only if we need to. All right, we'll see that later. Anyway, if you have a pixel ratio of 1, well, now it's looking great, and we're using the best version, the best anti-alias. Not the best, but in our case, it's the best. We are almost done. Hang on. The next part is about shadows, and it's going to be straightforward because we talk about shadows a lot, and we have our directional light that we create a shadow. This is why we needed this directional light. Oh, by the way, you can still tweak the shadow, the directional light. So we have both. If we remove the directional light, we get that. All right. And if we increase the envelope intensity, we get that. So you have to find the perfect tweak between those. We'll do that later. So let's activate the shadows. First, we can do it on the renderer. So it's going to be renderer. It's shadow map. You probably forgot about those, which is why we are doing it again. I could have made them at the beginning, but I want you to practice those. So shadow map enabled true. And we are going to use the type, which is the 3PCF soft shadow map. All right. Because it just looks better, I think. Nothing has changed, but still the renderer is now using shadow maps. Then you have to activate the shadow maps on the light. So it's this one. We're going to do directional light, cast shadow. Maybe you remember this one. True, like that. All right, no error. Check the errors always. Me, it seems to be fine. I still have no shadows because now we need to go through each element of the model, of the scene actually, because maybe you have like a cube or stuff like that, and activate or not the shadows. So we have to ask the question, can the mesh cast a shadow and can the mesh receive a shadow? But right now we cannot filter like say this one can, this one cannot, because we are looping on, we are traversing the whole scene. So we are going to go straight and say every object can cast a shadow and receive a shadow. I know it's bad for performances, but still let's try. Child, so we are doing it here because we are testing if it's a mesh. So child cast shadow. So it's the next slide. Oh, sorry, I forgot something. Yeah, before doing that, my bad. Let's optimize the directional shadow light. To do that, we are going to add a camera helper. So we can do it here. Directional light, camera helper. That was a long one. We're going to use a 3 camera helper. Remember this one? It was just to be able to see what the shadow map camera for the directional light will see and optimize the value so we get a better shadow. We're going to provide the directional light shadow camera. So it's the camera inside the shadow map of the directional light, inside the shadow of the directional light. And don't forget to add it to the scene. Scene add directional light helper. And now we can see the camera that is being used to create the shadow map. As you can see, it's pretty good actually. And we are just going to change its far value because it's way too far. All right, so the directional light were pretty good. Let's just change the far. So directional light, shadow, camera, and change the far to something like 15. Let me check the result. Yeah, we get something like that. It's maybe too far, but this way you can add, I don't know, a plane under this thing or stuff like that. It will work well. If you add more objects, maybe you need a bigger camera. Anyway, this is fine in our case. Now that the camera helper is fine, the camera is fine, you can comment or delete the camera helper like this. All right. So let's get back. Oh no, we can still continue on our camera directional light, shadow map. And what we can do is increase the resolution of the shadow map. The default one, I think it's 512. We're going to increase it to 1024. So yeah, let's go. Shadow map size set. It's a vector 2, and we're going to use 1024 like this. Still, we cannot see it, but trust me on that. Anyway, you can tweak those later. All right, so what I was saying before getting back to the directional light is that we are looping through every object of the scene, and we are going to activate the shadows. So cast shadow and receive shadows on all objects. Cast shadow, which is maybe a bad idea because maybe there is a lot of models, triangles, stuff like that, but still it's much more simple. Receive shadow, true. Finger crossed. And yeah, look at this beautiful shadow right here. Looking great. Really cool. And we can see it there. And we can maybe, I don't know, Yeah, we can see it pretty good, mostly on the base of this model. So because it's a dynamic shadow, we can change it like that. So realistic. I really like the way it looks. All right, cool. And if you don't like the quality of your shadow, as you can see, maybe it's not enough. I think it's more than enough. It's with this part. All right, if I put something like this, 256, we see that the shadow doesn't look great. It's not that bad, but it's not that great too. This is more than enough. 1024 is more than enough in our case. And this is it. It's time for the final tweaks. Now that you have everything set up properly, like the encoding, the light, the tone mapping, the environment map, everything is looking great. It's the moment where you just tweak until you get the perfect result. So maybe it's because you want to put your article, your product on your website so that people can just look around. So make sure it looks how you want your product to look. Maybe you did a great model in Blender or stuff like that, and you want people to be able to test it and see exactly what they are supposed to see. Well, anyway, just tweak the values until you're happy. You can tweak the light and stuff like that to make sure that the light comes from the same part. You can also change, I almost forgot about it, the environment map. And as you can see, we can test this one. And it looks like this. Looking great. The light is wrong. See, the light comes from here, but it comes from the right. So maybe you can change the position of the light. Let's test the number 2. Yeah, looking great. The light is almost right. And let's test the number 3 just to have a look at it. Yeah, it's looking great. Yet again, the light should be here. So maybe you can just change the X and move it there. So it's not the X, too bad. It's the Z, something like that. The X is supposed to be 0. Yeah, it looks like this. Yeah, looking great. See how cool it is? All right. Wake up. We're going to test the burger. Okay, we are almost done, but at the beginning, the problem was about the burger. So in the previous lesson, it was a burger problem. So let's use a burger. And I have a bad news. We are going to have a problem. So the burger is located in the models folder. You can use yours, but I recommend using mine just so we get the same result. So it's hamburger. I always say burger. Sorry, it's hamburger. It's a French thing to say burger, and it's not GLTF, it's GLB, like that. All right, this is our burger. It's way too big, so let's fix that. First, we can change the scale. 0.3, 0.3. We're going to have a problem, and I want you to have the problem, so put this burger on the scene. We don't need to change its rotation. And this is our burger, yeah. Welcome back. But what is that? What is happening here on the textures? And yet again, I'm not an expert about that, but still I will try to explain to you what this is, what the bug is. This is called those artifacts. So it's not like we put the burger on the grill for too long. Those are called shadow acne. And it occurs on both smooth and flat surfaces. So this is a smooth, round, I should have said round surface, but also flat surface. And it's a problem about precision with the shadow map. And I will try to explain to you with some drawings yet again. Yeah, I need another grid like this. All right, I'm going to draw something. Let's say this is our light. We are seeing our scene from the side. All right, this is our light. It looks like this, I don't know, and it sends, I don't know, like lights in this way. This is our burger. Just like the sphere, it's our burger seen from the side, and we just focus like if we were inside of the cube, like it's a slice of the cube. All right, we cut the side of the cube. When we are using this light, it's creating a shadow map. A shadow map will look something like that. All right. Yet again, it's seen from the side. When the light will register the shadows, so is there an object here? Then it will cast a shadow behind. The light will register that, here there is shadows, here there is an object, here there is an object, here there is an object, here yes, so no, 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 yes, 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 no, yes, a little more, yes, okay. And you can imagine that all the rest is inside the burger. All right, this is the inside of the burger, and we get green everywhere. And the rest is not. All right, this part is not the burger, so it should not cast shadow behind. Why? So this is what the shadow map will save. So this part or the burger. Then if something is behind, let's say there is, I don't know, a plane far away, well, this shadow map will use that. Yes, there is something here. So what's behind should be in the shadow. All right, this is how the shadow map works. But what's happening here is that the shadow map will also apply on the burger itself. And what's happening is that the shadow of the burger is happening on the burger, because right here, as you can see right here, this pixel, so it's not a pixel, but this part is inside the burger. So this will be shadows on the burger. So it's the burger creating a shadow on the burger. This one too, as you can see, we have shadow here, where this whole thing of the shadow map, we will apply a shadow on the burger. And this one too, and this one too, not this one too, and this one too. And this is exactly what you are seeing here. All right, it's those kind of triangles. So this is a slice seen from the side, and we get this result. It's the burger creating shadow on itself because of a precision issue. The solutions is shadow bias and shadow normal bias. The idea is that when we are going to save this burger shadow map, we will move, wrong side, we will move the object by pushing them, like we are pushing everything there. We are pushing the burger on its normals. Remember the normals? Where we are pushing the surface on its normal, and instead of the burger being the white surface, it's going to be the purple surface. And this way, or actually it's maybe in the opposite. Oh yeah, we are pushing them on the back. So it's going to be there, there, and there. And we get something like that. And this way, when we save it if it's in the shadow or not, well, this one, so it's going to be hard to remove it, but this one won't be in the shadow, this one won't be in the shadow, this one won't be in the shadow, well, all of this won't be in the shadow. All right. So we have our burger. We put back the burger like this, and this one won't be on the shadows like that. All right. So this will be in the shadow. Yes, 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 yes. And then when we will apply the shadow map on the burger, so the burger is the white one, well, this one is not here, this one is not here. So the shadow map, it's kind of a little further, and then the shadow map of the object won't be applied on itself. That was hard. I know. I have troubles explaining this part. Anyway, I really wanted to explain to you this, but what you can do is simply tweak it by using the bias and the normal bias properties. All right. So it's about the light, because it's the light saving the shadow map. So go to your directional light. And what you can do is play with directional. And for us, because it's a round surface, we want to move the surface just like we did here. So when we are saving the shadow map, we want to move the surface further on their normal. So it's the normal bias. All right. So we do directional light, shadow, normal bias, and you just have to test values. So you start really small, like 0.01, and you test if it's gone or not. Is it gone? I can still see it here, but it's gone on the top. All right. So we can move it a little further, maybe 0.02. Yeah, now it's gone. I don't know why I did 0.05. Anyway, let's use the value inside the exercise, and we get this. And this is looking much better. All right. It's like when we save the shadow map, we shrink the burger a little so that the burger doesn't create a shadow on itself. All right. Don't put too much, because the shadow will be wrong. If you shrink the burger too much and you put a plane behind, you will see that on this plane, it's like a tiny burger. So the shadow will be wrong. So just use the right value. Between 0.02 and 0.05 is more than enough. You might see this shadow acne on flat surface, and on flat surface, I think it can work with a normal bias, but maybe you should try the bias. It will mess less with the shadow and you will get rid of the shadow acne. All right, that's great. Bon appétit. See you in the next lesson.